And we're back. Hi, everyone. Let's continue our categorical logic presentation here. Last time you learned some of the basics, right? There's four different kinds of sentences, different kinds of statements that we will use. Just like we had four different kinds of logical operators, right? Here we have four basic sentences, and that's all we really have to deal with. And we can see that each of them has a kind of structure to it, right? Here we see what's called a quantifier. We see how many, what we're talking about. We're talking about all of them, all of the members of this group over here, none of the members of this group, or some of the members of this group, right? And the thing that we're talking about is the subject. So in this first sentence here, the subject is diamonds. That's what we're saying something about. And the predicate is the thing that we're saying about it. So the subject is diamonds, the predicate is precious gems, and the same goes for the rest of the sentences here. Right? Every time you get this first word right after the quantifier, you know that's the subject. And then we get the copula, are, and are not. And then whatever comes right after the copula is the predicate. Okay, so hopefully you can just sort of remember that. So when I say subject or predicate, you know exactly what I mean. Okay, so let's move on here. I had you do that exercise. All right. Okay. So let's learn about Venn diagrams. That's going to be the basic bread and butter. That's going to show you whether or not an argument in categorical logic is valid or invalid. It's a nice visual way of being able to show that an argument is valid or invalid. Okay. So first, we can just represent a single category of or group of things. Remember, these are all about groups of objects or things, right? Either we're talking about all of them, some of them, or none of them. But let's say we wanted to talk about a particular category. Well, let's learn how to represent that with a Venn circle, right? Pretty easy. So, oh yeah, quickly just to tell you what we're about to do, right? So you'll learn how to represent just a single category. Then you'll learn how to represent a categorical statement, right? Where you have a subject and a predicate. And then you'll learn how to put two premises together into a whole Venn diagram, and that will allow you to be able to check a categorical argument for validity. And it's very interesting that if you just get to this part, if you can learn how to represent the premises using Venn diagrams, then you'll be able to see very easily whether or not an argument is valid. Because if it's valid, the conclusion just sort of shows up. You'll see what I mean by that. That sounds mysterious at this point, maybe, but it's going to make sense. Okay. So let's first just do a really simple thing. Just represent a group / category, class, set of things. Let's say we wanted to talk about the class of squirrels, right? The category or group of all squirrels that there are. Well, all we really have to do is do a little circle and write squirrels under it, and that's it, right? So anyone can do this. This is how you represent a class of things. Write the class of what it is at the bottom and put a circle right on top. Okay, super easy, right? Hopefully. But now what we really want, of course, is to be able to represent one of those four basic types of categorical statements, right? We're only dealing with those four, right? The universal affirmative, the universal negative, the particular affirmative, and the particular negative, right? All S's are P, no S's are P, some S's are P, some S's are not P. Each of those four. So we just need to be able to know how to represent those with circles, and then that'll be the basis for categorical logic. So remember these four types of statements. I just said them, but here they are again, just to remind you. And this is something you should just know. You should just get these in your head. Each of these four kind of statements. Okay. Because there's only four. That's easy. So this ends up not being that difficult either. Your first step is going to just to make two circles this time, right? One to represent the subject term and the other one to represent the predicate term. So let's say we just have some random statement. Let's use a universal affirmative, right? All S are P. All squirrels are omnivores, and omnivores a creature that eats not just vegetable, not just meat, but multiple things, in case you didn't know. And squirrels are omnivores, so this statement happens to be true. Okay, so first we just make that circle with squirrels again. We did that earlier, right? Because that's the subject term is just talking about all the squirrels that there are. And so that's what we want to represent with the little circle and the little label underneath. Then we make another circle to represent the predicate term, omnivores, and we just make them overlap like this. Okay. Now we have not represented our statement yet. So we're getting there. This is just setting it up. For all of the 4 statements, this is going to be your first step. Write the subject term on the left over here. I always put the subject term on the left, just like as you're reading it, right? It's the same sort of thing. See, squirrels is on the left of the sentence, omnivores is on the right. So you can note to do the same thing when you do the Venn diagram. Yeah. Now, to say that all squirrels are omnivores, we're going to represent that by blacking out anything that is not part of the omnivore circle. Right? So the black here represents a complete absence, a complete void. It represents death, nothingness. Nothing lives there. Right? We're saying there's no squirrels outside of the omnivore circle. If there were, then there would be some squirrels that aren't omnivores. But this statement is saying that all squirrels are omnivores. So there just aren't any squirrels outside of this overlap, right? All the squirrels that are in the squirrel circle are right here in this little area that also happens to be inside of the omnivore circle. Right? So you can think of it this way as well. Let's imagine you round up all the omnivores in the world and put them in a big circle. If you go look inside of that circle, you'll find squirrels there. Right? If we rounded up all the omnivores and put them all together, you're going to find some squirrels in that omnivore circle. If you look outside of that omnivore circle, you're not going to find any. Right? None. You're not going to find any squirrels outside of that circle of rounded up omnivores, because assuming that we've rounded up all the squirrels and all the omnivores that there are, and they would only be inside this omnivore circle. There wouldn't be any squirrels out there. So that's why we use that blackout sort of technique to represent the idea that there's just no squirrels in that part of the circle. Yeah? All the squirrels that there are also inside of the omnivore circle. So that's how you represent a universal affirmative. Right? We're saying all the members of the group squirrels are also members of the group omnivores. So all universal affirmative statements are diagrammed in that way. So we can just have a general chart here. This is what every universal affirmative statement looks like when you represent it categorically. And the S and the P, they stand for the subject and the predicate. But they're also like variables. These can represent any group or category of things or objects, and so can P. So whatever you want to put in for S and P, right? Trees and wizards, it doesn't matter. Anytime you say all members of this category are also members of this category, this is how you represent it. So now you've got that one down, hopefully. What about a universal negative statement? Right? A no SRP, where again, we can put anything for the S and the P, and we're going to end up representing it in the same way. Let's just take a random statement. No cats are humans. Another true statement, though they sometimes have human-like qualities. They're not literal humans. So they're the same things. The beginning is the same, right? Make 2 overlapping circles with the subject term on the left, the predicate term on the right, and of course the subject term is cats, the predicate term is humans. Just like that. That's your first step. Now we want to represent the fact that none of the members of the cats group are in the humans group. Right? So we want to say there's none in this overlap, whereas before we wanted to say they were all in the overlap. Now we're going to say, no, there's no cats. There's no cats in this circle that are also in the human circle, right? Because there's no cats that are humans. obviously, right? So that in that case, we just use the same blackout technique, and we just say nothing in here, nothing in the union of cats and humans, nothing in the overlap. There aren't any cats that are also humans, right? And there aren't any humans that are also cats. There is just nothing in this cats-human overlap. If there's any cats at all, they are outside of that part of the circle. They would all be outside of the human circle. Yeah. I hope that makes sense visually. It might be a good idea for each of these four to really study them and understand why we're doing the symbolism like this, right? So really understand that this blackness represents an absence. There's nothing over here. If there's any cats at all, they're outside of the human circle, because that's what we mean when we say there's no cats that are also humans, right? They're outside of the human circle. And so all universal negative statements are represented like this. Okay, you've done about half of them. Right? 2 out of 4, we're doing good. Hopefully it's clear so far. All you're learning to do is just representing each of these 4 types of categorical statements using circles. So what about a particular affirmative? Right? A random statement, and these literally are random. I usually just have my brain come up with something random. Some dads are grill masters. And over here, I don't mean the actual product grill master. I mean somebody who's master of a grill. There are some dads that are. There are some dads that aren't. But here we're saying, well, at least some of them are. Right? How do we want to represent that? First step is the same as before. Just make the 2 circles to represent the subject and the predicate and make them overlap a little bit. Then what we're going to do, instead of using the blackout technique, because we're not saying anything about all or none, we're saying that there's, when we say some, get used to that meaning at least one. Right? So even if there was just one dad who was a grill master, we would say it's still true that some dads are. So maybe that's a little different from ordinary language, but just imagine it that way, that some means at least one. Right? So we're going to put a little X right here, right in the overlap. I'm going to say there's at least one guy out there who is a dad and also a grill master. Most likely lots, but we're saying at least one. Right? Some beings exist who are dads and grill masters. Yeah, do you see that? Just a little X to represent at least one. There's at least one member of the group dad who also belongs to the group grill masters. So total black means there's nothing in that area wherever you're shading. A little X means there's at least one guy. There's at least one thing within the area that's where the symbol appears. And here, that's the overlap between dads and grill masters. And so any statement, any some SRP, any particular affirmative is going to look like this. So really, again, you're just learning 4 basic types of statements and how to represent them visually. It's not that complicated, really. It's a lot like I said in propositional logic, like learning the rules of a game, and the rules are pretty simple. So now we're on to the last one already, right? The 4th basic type of categorical statement, the particular negative. Some books are not bestsellers. How do we want to represent that? Well, you might already have a pretty good idea at this point. Maybe you can guess. You'll at least know by now what the first step is, right? You just represent the subject term on the left, the predicate term on the right, have a little bit of overlap. And now we already know that the X means at least some, right? At least one, rather, right? Some means at least one, and we represent it with an X. So what we want to say is, there's at least one book, right? There's at least one book that's not in the bestsellers circle, right? So there's a member of this group, books, that is not inside the bestsellers circle. So that's pretty easy. We just use that X again to represent that there's at least one member. And now, instead of putting it in the overlap, we're going to put it over here. Right? There's at least one book, i.e., there are some books that are not bestsellers. Yeah, I hope that's clear. So this represents the fact that there's at least one member of the books group that is not inside the bestsellers group. And so any particular negative at all, any sentence with the form some S are not P is going to be represented in this way visually. So that's really a whole lot of it. That's enough to get us started for now. Next time I'll show you how to actually put those together into premises, and then you'll be able to see if the conclusion just shows up on its own, and if it does, then it's a valid argument. You know. So just to review, here's each of your types of statement. So this is what you should learn, and it's easiest to learn if you understand why the symbols work the way that they do, right? That black means there's nothing in that part of the circle right there, and the X means there's at least one, which is what we mean by some in this context. So look this over, go back, maybe practice. I don't have any exercises for this because really I'd have to have you draw circles. I'm not sure how I do that. You'd have to take a picture or something, but I don't want it to get too complicated. So for now, I'm not going to have you do any exercises, but please take some time to study each of these four and really get them in your head. So then that way, next time when we actually use the visualization technique to see if the argument is valid, you'll know how to do it. You'll be comfortable doing it. Okay, and as always, please feel free to shoot me an email if you have any questions, or can I make this into a discussion? Yeah, since I don't have any exercises, I'll have a discussion underneath this in case anyone wants clarification on anything. All right, well, have a nice rest of your day and have a nice weekend, and I'll see you soon. Bye.